Hello, my name is Brandon Galvez. I am here to present information about the bus system, accompanied by my colleagues Sebastian Marquez, David Leal, Nico Gonzalez, and me. And I'll be discussing the definition of the bus system. Definition of the bus system and in the context of computer architecture. And the bus system refers to the set the communication lines, channel or physical paths that allow the transfer of data, addresses and control signals among the various functional units of a computer and such as the central processing unit (CPU), the main memory, and input-output devices. I can be considered the nervous system of the computer, as it connects internal components and enables them to operate in an convenient and efficient way. The bus system is not only made of wires or physical lines but also include protocols, time, timing mechanics, and arbitration processes that determine who can use the bus and when. Generally, a bus is divided in three main types: the data bus, the address bus, and the control bus. And the database carries the actual information being processed or transmitted. The address bus indicates the memory location or the bus being accessed. The control bus manages commands and synchronization signals and coordination necessary for correct communication. In other words, the bus system is the infrastructure that ensures the CPU can communicate with memory, read data from a hard drive, send information to the printer, or receive input from a keyboard, making the coordinate and efficient operation of the computer system possible. This is what we know today, or this is definition of what we know today as a bus system. Now let's move of to the history of bus system.
History of the bus system. The concept of the bus system has evolved alongside the development of computer since mid 20th century. In early computer views were very simple as they only connected with the CPU, with the memory and few basic peripheral devices. These early buses were dedicated and point-to-point, meaning each device had a direct connection with the CPU, which made expansion difficult and expensive. With the rise of microcomputer in the 1970s, especially with the introduction of the IBM PC in 1981, the first standardized bus appeared, the ISA bus. This bus allowed the connection of expansion cards, and video cards, sound cards, and disk controllers. Although it had limited speed, its advantage was standardization and ease of inspection system. New buses such as PCI emerged. PCI was faster and more efficient, offering higher data transfer rates and better results. Much later come the AGP, specialized for graphic cards, fluid by PCI Express, which is currently the most widely used standard, offering high speed transfer and multi-lane data channel. At the same time, external bus systems were developed, such as USB, which allowed the connection of peripheral devices easily with plug and play functionality. Technologies like Thunderbolt and Serial had further improved speed and connectivity in modern systems. This evolution has made computer systems more powerful, flexible, and scalable, allowing users to connect a wide range of devices quickly and efficiently.
The general characteristics of the Bush system are several essential characteristics that ensure its proper function within the computer architecture. A basic composition and typical bush includes the main subbuses. A data bush carries the actual information to be transferred. Um, Address bus identifies the destination memory or the bus. The control bus sense control, synchronization, and management the signal. El shared, el shared topology. Multiple devices usually share the same bus, but only one can use it at a time. This is managed through arbitration technologies to decide which the bus has access. Speed and bus width. The number of bits a bus can transmit in parallel is known as the bus width. For example, a 32 bits bus can transmit 22 bits. Simulation speeds combined with width determines the data transferred. Uh, the, the synchronization bushes bush can be synchronous using a common clock signal or asynchronous usually control signal instead of the shared clock. Synchronization is key for correct date communication. Uh, scalability. Many bus systems are designed to allow connection of additional devices without resetting the entire architecture, enabling easy system expansion. Compatibility. Modern buses often maintain a backward compatibility, allowing older devices to work with newer systems. Arbitration on access control. In systems with multiple devices, it's essential to decide who control the bus at any moment. Arbitrary methods include fixed fixed priority, round robin, and CPU control access. In summary, the bus system is a fundamental component that enables the communication and integration of the parts of computer. Its design and evolution have been crucial to the development of modern computing.
Is divided into several types depending on two functions that perform within two systems. Two train main types of bus in computer are database. The database is responsible for transforming information between two different components or two systems. It will determine two amounts of information that can be transmitted in a single clock cycle. For example, a 32-bit bus can send 32 bytes of information with, whilst a system for bytes can send 2 amounts. To speed or to data bus directly affects two systems to perform as faster data transfer imports processing and efficiency. Address bus. To address bus is used to identify memory location or special deviates within two systems that achieve this as said. Two number of lines in two address bus determines two amounts of memory to process can address. For example, a 32-bit address bus can address up to 4 gigabytes of memory, while a system 4-bit bus can address much more. Control bus. To control bus handles two signals to control the name and control two operating or stone computer. Through these balls to separate cell needs null to indicate what to read or write operation or to being performed what to deviate is ready to receive data or or is there is an error in communication. So, some example of signal in tune control bus is read, write, interrupt, and clear.